So as I said before, we are simple, very simple ship.
Bless you.
No, thank you. You can't keep your eyes off this for a second. You got the air in there, you won't see. As long as you got the air in there, you won't see anything. Can we use that now? No, don't worry.
I need lights.
You couldn't get rid of that much air there. Can we change things inside, or do we have to open it? Right?
We have to open it and what?
If we have to change the material inside.
Yeah.
Sure.
I need that. We need just Can you disconnect this one?
What do you do? You change your guns.
Yeah.
So now you're on the couple upside outside.
Yeah, inside and outside.
We got to do this stuff for half an hour.
Most of the transformation goes to the bottom. Did you disconnect?
No. Connect it to here. Because if you put that really through the top, then the rest is cement and all that.
This motor is very powerful. So it's better for me to stay from here.
You still sit at 12, 14 Tesla there.
But you see, Gans in this circle is completely different color. Here. Gans, this circle is completely different color. Oh, yeah, this ground was circulated this is jump. It's circulating ground
Where is the magnet?
yeah.
Put a flame water and steam
Salt water.
Absolutely very, very nice cold
All guns.
yeah. So, we are moving on to there, and maybe I will send you another this week. The agriculture side. Let's go.
This one, make a hole. I'm going to put this with you.
You know, become part of that. the should I bring the light or do you see? I think it's We are back with the same pot upside down. Dad started with the pot upside down before, huh? You remember? Originally this was.
When you put inside the other ones, you need to put it in this direction.
What are you doing? Can you place the cup underneath? No, we want it the other way. Ah, not yet.
Can I ask you a question?
Very Can you make it all half piece like this? Just push this and just to cover here. All we do
I can do this together.
because it's high speed, you don't get stuck. When you go high speed, you get stuck. This way, you have the cup, you look at here.
This one is not there. This one is big.
It's not backwards from last generation. Are we live online?
Yeah, we were. I hope we are still, yeah.
On the top, you're asking a question, what's on the top? The top is the total value of all the fields in and out of the sphere of the plasma in the center. So what you ask, what's on the top? If you put a line on a 0, let it come back. If you put a line on a 0 here, if you can see it, the area, this is peaks at 12 Teslas. So this is our 0. This area, in respect to 0, is the total field received, entered, or exited the sphere of the plasma of the cores. Because they're asking what's the white line for. So this is more or less your total energy area in this zone, which has gone through the plasma. We are trying to go as far as possible below 0 to reach 50 micron Tesla, which is the Earth atmospheric. But these peaks, what you see, is plasmas which rejected by the core itself. That's a collection of 4 cores simultaneously releasing enough fields that it can depart from the imaginary plasma. Don't forget that these fields we see is from an imaginary plasma which is in the air and not from any of the cores. So now it shows our plasma is getting fed by the mother from the top, because what you see on the green line is what is going away from the detector, and when it goes away, it means it goes to the top principal reactor and it comes down. The red is the y-axis, and so the fields are going away from the reactor, from the detector. So this is what we see as going to the top reactor, the principal reactor, and then coming down. So this is what we see as a flow. This is a 40,000 Tesla, 40,000 millitesla. This is 40 T. We are looking for more continuous lines than the peaks in the total environment. I forgot what you said. Thank you. Now you're in a live situation. The blue, when you look at the blue here, the area under the blue shows the energy which is released totally in one pulse. The duration and the height should give us the area which gives us an indication. Something which you have to look for all the time. When you look at them 14 and 12, you have to find a matching weight here. Then you see where it comes in. When let the graph comes out, I explain that you can understand. This is now 42 Tesla. This is 15 Tesla. So when it comes, you see the 12, 14 changes. We started from 1108. So we are gaining weight, and that's what we expected from our performance before. As the direction of the flow shows, the field is coming down through the center top core, and that shows the increase in the field in the gravity. What is important for you to notice here is if you put a line in the center of the graph, I don't know if you can see it, what is green and below is the field which are going away from x-axis, from the y-axis, the detector. So this shows away, which in this case, because the y detector is on the top, means that the flow of the field is north to the top of the setup, which this indicates that the south pole of the system more or less sits on the top end. We get a confirmation of this because you can see the Y is -2. So in this setup at the moment, since Sunday, the core is got a south pole on the top, where before it was on the south and then the entry was on the bottom. The other point you got to understand with this is that he decided to go. We come back again. Is it done? Yeah, just 1 second. I'm explaining something live on the live stream. So what you see here, whatever is above this line, especially with the blue, shows magnetical, which means the field coming out. Anything below this line is gravitational. So system is continuously transferring from magnetical to gravitational. But what we see more and more in past couple of hours is the increase in continuity of the magnetical, which means it's coming out towards the Z detector. And they are in line with what is coming through the Y. The Y is going away, going into the top of the top core, and is coming through the center. So now we see increases, continuous increases in the Y, and we see the increase in the Z axis. The point is that we're seeing some continuity. A lot of these jumps that you see is mainly to do with the bearings, which are on the motors. If you could go back into the zero bearing or air bearings, then or cushion bearings, we should get a continuity. That's for the next future. But what you see as red going up is what is getting absorbed into the system from the environment, from magnetic fields of the environment. And most of the time they follow the Z line, because as the Z comes in, it hits the Y and X at the same time, but it gets absorbed and it goes back in the Y and it comes back. So this process is very clear. We have a pole system more than a gravitational system, and this is very much a protection field zone. So you protect your field and you see what you can get. The area should go below 20-25 millitesla. The fields we are producing is too high, because on the other detector which we have inside the cage, we are at 50 microtesla, and we are just about the Earth gravitational field. So in this position we should reach about the same, but we are too high at the moment. So we see how it goes. And now we see we're going to 16. That's what I said. For the first time we see 12, 14, and we saw 16 now. This means the system is gaining weight. And we started from 11.08, now we are 11.016, which means we added about 80 grams in 4 hours. So we are absorbing fields and we're increasing the fields. And this is what I said. If the system does not turn, which means if we do not go positive in this field of the 14.6 or 14.3, then we have a sinking ship. We are submerging. We got to see what the data reads tomorrow if it follows the same procedure. So now 16. You notice something very interesting, that the change of the numbers here can immediately be seen in the blue line. When you have a blue line, when the gravity increases, then you see the 16. These peaks in the blue, these are an indication of the field getting rejected. They don't really show much as interfering with the system. These are releases of pulses. These are needed for what you call the protection system, and it's important in the structure. But now you see the peaks in the weights when it goes up. You see peaks in the reverse, which is the gravitational. Anything above the zero line is magnetical, that's atmospheric, and anything below is gravitational. Let's see. How will you get the fields to go? How will you get the fields to go to opposite polarity? It's the flow of the current. It's the flow. No, you're not even sinking. What are you doing? What do you expect? You got no holes in there, you got the rest of you. Please don't move like this. It doesn't make you swim. That's what I said. If you have a cap, you put it on and twist it and instead. And this is not factors of the work because then you can increase the density of the gas. This is how it works. You don't need the cap. No, you don't want to stay here where I'm going. But it's not working. It's not put something magnets. I'll try to change the density of the all night I'm here. What was the question they asked? How do you get the field of the field goes to opposite polarity due to the current of the plasma flow. It's a current. It's literally like a magnetic field, like a current. You go positive to negative. When the flow changes, the density of the flow changes, and then the current flow changes. In a plasmatic condition, you get a change of polarity. And it's like a saturation point. That's how the systems like the stars change their polarity every 11.5 years. Because the material in the center core is constant, so it has a given time of saturation. It's, if you understand what we explained in the health section on Friday, it's how you charge the lung. When it gets to the point, it discharges. In the condition of the dynamic system, which is not like a heart or lung, you get the flow. Literally, the field force of the plasma in interaction with the magnetic field of the plasma pushes it and turns it over. Because even though you have a plasma inside the center of the, like the sun, you still have inertia factor of the plasma, because inertia is not to do just with the matter. Even the plasma has its own inertia. So when the gravitational magnetic field of the whole lot interacts with the inertia of the plasma, the field forces changes over. Just it comes to a point that it can take over and it rotates, creates motion. But in a plasma condition, we call it a plasmatic flow, current flow. It's not a current as electrons, it's a current flow as a gravitational magnetic field totality. There, we still have 17,000.
Do you need opposite polarity for weight decrease?
Weight decrease?
Weight decrease. Here.
No, you need magnetical section to increase, because we don't work with systems which is like repulsion. You work with positioning. When you have magnetical, what we call atmosphere, which is rejected, you increase the power of rejection, so you push away. So you increase the boundary of the rejection or the strength of the rejection, so you create distance. And that's how it's done. You don't bear, and if you want to get attracted, you decrease your magnetical, which is your rejection, compared to attraction. What you literally need to do, in a way, if you look at the blue, lines here, these are magnetical, these are rejection, these are what's coming to detectors. And then what you see at the blue in the bottom, these are what gravitational, get attracted. You have to make sure you increase this way if you want to get attracted, or you want to get repelled, you increase this way. It's like two hard balls hitting each other. You bounce off, but at the same time, you're in the same circle of the magnetic gravitational fields. We showed this in a very, very near time. We are running a test on the side, which I don't know if you can see it. This shows 0, where before it was 1.9 millivolts. This we are measuring the current flow in a plasma in a separate reactor, which is sitting about 2 meters, 3 meters away from this. And it's come down slowly, and we see where it's going to go. If it's going to go to negative and build up, if it goes to negative, then it shows change of the flow of the plasma. This is totally gravitational now. It's more gravitational than magnetic. This is a 40 Tesla peak pulse. You see any changes in the weight corresponds with the peak of the blue. If you get a deep cut in the blue, means gravity increases, then you get a peak. This is positive increase. So we see continuously, system is not taking much, it's giving to keep balance. And then you see this is 30, no.
It's 50, I think.
50 Tesla. The flashbacks you see, when you see flashes of before reading, this is when the plasma is trying to find its balance. I think Marko can explain this. He was explaining this yesterday. Why do we see these flashes before we see balance again? You know these flashes we see from the peaks?
Well, their fields are trying to get a balance between each other. It's when there is a peak, and then they try to get in balance something. Questions. So it will shift back to opposite polarity in time?
Yes, it should do what the plasma decides, and the total environment decides when it's going to change polarity. It's the first time in nearly 4 weeks this has been running that we've seen negative. And it just happened over the weekend. And if we go over the time, if it's recorded, anybody can go when this change happened, because I don't know where it is, then we can analyze it in the workshop step by step. We should see how it happened and the way it happened.
Elia is online also. In some way, works central energy channel flow described in energy in medicine.
Yeah, because as Dr. Elia says, it's the same way as the Y goes negative. I try to, as the Y, which is the green lines, which goes into the minus, this shows that the energy from the reactor itself is feeding back in the reactor from the North Pole or the entry pole, which has become the which is changed. So in time, when you change the field enough, maybe if we time it, then we can find a cycle of polarity change. But we don't know how it can be changed, because now since this data was taken, we have increased the Gans content of all the 4 reactors. So we are going into a new condition to see if we can go for the limit of 100. It's amazing. I wish I could be part of this. I do. No, the main outside. You have CO2 outside. So the centimeter, you see a CO2. So if you can figure out the oils of the outside, maybe this is it. Maybe. But because how much of the life is absorbed by CO2 of the outside? If not the outside, I'm going to get a bit. So my point is that the number in the capacity in order to live, that creates no election of we can never fail, we just extend to the life.
Maybe some smaller
Does anybody know what the time is?
20 past 7.
He won't go. No, it's too small.
What is inside? What's what is it? This one gives us in custom. You will tell me who this.
I just went to the picture. It doesn't actually opens up. It opens up, touching the top. Yeah. I use this quite a lot. I'll show you information. This is ready. When you do the same thing, you do
In some cases.
Wash your and don't rub it. You know what they've done? They've Chinese show how they're injecting the roof of the fans. It just goes just to the roof, nowhere else. They're going to farm like wool. They're going to country, they're going to see it, they're going to farming
They're using Gans.
Just go over it. You won't drop because it's smaller. You can't touch it. The noise changes because of the you need more of it. Hopefully, you can stop.
Yeah, and you have to do it.
Ah, you're leaking. You're leaking. You have no water. You have no water. It's like it. After you go, please, 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 just the water. Yeah, I'm sorry, but I didn't have to. I have a small bottle now.
You want to say something? It's live.
You can see.
Yeah. Pick it up. Which one? No.
You can't go any closer.
Oh, it's, here is a little bit of delay.
Yeah, no, I'm waiting. And now again. Good. No.
Yeah, just yeah, it's difficult to say.
And what if you tip? I know where the problem is. Just 1 second.
Take this chair away to put it a bit higher.
Is it better now? Oh, hey. Can you see better?
The other numbers are okay, but the bottom number, it is says poor.
Better or not?
Being said yes.
Ah, oui.
We can see the numbers. Looking in its mirror.
Better?
It's okay. I want to tell you something. It's okay.
We can't read the bottom.
You know something?
It's not like moving inside.
Reactors are half inside.
Yeah, because this is.
You got to. Is it better now? Let's see. Now, if they see it, it's okay. Or do we see the figure is good enough?
Better.
These things are very hard to please, huh? Move it this way, move it that way.
It's a little bit of delay. So
I'm going backward. I came too forward now. Do you know where company is with you? Now it's fine, okay. Let's see the- Something which is very interesting to notice is that we started with 1108 and we've been up to 1116 and we are back down to 1110. That's the voice of our mascot. He wants to play. So you see very much. Can you hold it? He wants to play with Armen. Yeah. Um, the position of the change is very much in line with blue. You see peaks, this is 11,000. It's a very high peak and narrow. We opened the reactors over the past few days. They don't see. We opened the reactors over the past few days. We have reloaded. We have kept the speed at 2,000. And what now we see is is a difference in performance. And in the long run, we are not looking for the peaks, as I said before. We are looking in the stability in the X and Y below 50 microtesla. So in time we'll change and we'll see how we can produce it. And now we literally have different type of reactors running. And if I go back up, you see something interesting. You haven't noticed this because you are far away from here. Let the picture come up. When I see it, I know you can see it too. I have moved the picture up. Okay. If you can see, in the background, we have added a magnetic shield on the top. This magnetic shield is, you don't see it because it's in the background of a black screen. But this, now you can see it on your screen. This magnetic mat, has been put there. It's a special because it's got a back cover. It does not allow fields to go above it or above to come in. Reflects everything back in. And since we put this on, we see increase in the peaks. So we have confined the fields. Caroline, can you pick Topoli up? He's talking. So you see peaks in the Y, in the Z axis. And these peaks have you can explain the condition and why they come in and the way they come in. You see this is about 40 Tesla. So the high peaks we see is not coincidental, it gets repeated. This is 8 Tesla, this is 11 Tesla. We have to go, we show that. There is something which you can see in the far distance. I'll try to, if you can see it, if you can forward the camera with the computer away, please. If you see in the far distance, let me see the picture. You can see the picture, it doesn't move.
Try to look at this picture.
It's okay. It's okay, it doesn't matter. We are not there now. We are not there yet. In the far distance, you see a small reactor on the upper left corner. By the time I get to it, your pictures will see. This is the no, this is the new small reactor.
That's the car.
I think that's why it is in. This is our newest reactor which has joined the set. You can see it, I'll just show it, it must be on your pictures now. So this is the 4th reactor in that setting, and in a further distance you see the another soft formation within a cascade that we keep that for measurement of the actual gravitational magnetic field of the reactors. These are all reactors, the big reactors. So that's far end one reactor. In the middle, you have another set of reactors, the star formation. And now we are concentrating on running 3 reactor sets. The ones you see in the middle, there is no motor running. We control the plasma flow through the gases, through, as I said in the book number, what do you call the paper we released recently? Is that where the triple core is? The triple core sits inside the far distance reactor in the box. It's the only triple core we have. The one which is right, you see in front of you, I think if you put that down, you can show it. This of me walking back and forth. Leave that here, so they can't see it. It's okay. Yeah. Marko is going to show. Yeah. No. Yeah, that's perfect. That's perfect.
Okay.
It's perfect. Nobody's moving around with it. So, what we're going to show you, see live operation. I'll wait till your pictures come up that you see what we are explaining. Where Marko is now is the. Let me put the picture up a little bit. Your picture hasn't come up. You haven't arrived yet. There you go. You're there now. You just arrived in pictures, yeah. Okay, what I've done, where Marko is, that we have 4 reactors. The 3-core reactor is inside. We have a star formation in it. It's magnetic field controlled, which means these covers you see especially ordered for us and is kept. We can create a zero field condition, only what's inside, but at the same time its interaction can interact outside. It's the special setting inside, which is a star formation. The next set you see Marko walking into now. This is the second set of star formation. The 2 reactors, there is one behind you see with a gray top. The reactor which Marko is showing you now is the new aluminum. Is it rotating? Has it started rotating? Has it started rotating? Not rotating. Okay. We don't know because this is creating. This is a small reactor. Can you pick it up? We can see it. Is it very high? Clockwise. No, it's anti-clockwise. If you see, I'll try to put this digital reading in front of you. This is the first time. It's okay, no problem. You can see it. This is, if you can see the light coming on, you should be able to see it. The digits. This is the first time the figure is coming up. I can switch it on till you will see it. This is the first time we are measuring the current within a plasma in this operation, which shows what we have: a center core pin, which is a nano coated. Then we have filled up. Armen is about 20-30% CO2.
Yeah.
20-30% CO2, and then we have a what do you call it, graphite contact points, which we measure the current or the voltage between the center core and outside. So this shows continuous change in the voltage in the plasma. This is the first time in this setup we have this opportunity to do. So we can measure the total field strength within the core. We can increase the speed to see how much plasma voltage changes. Most probably we can measure the current within the plasma too. And then we can change the density of the material too. So as we inject more material, we see how the voltage changes. And then we see how this affects the operation of the other reactors too. Out of the two sets which Marko just showed you, we do not use any motor running. All the motions are created through the rotation of plasma, through gradient of the plasma between different cores and in positions. So we go back into the monitor because it's about 8 o'clock and we're about to leave. And Armen is busy trying to imitate a lighting system. We can rotate to him in one go. You can see it. Where are you, Armen? This is a reactor. No, we don't see you, Armen. Wait. Be patient. Be patient. Yeah. You see it? This is the new reactor, which works like a light. I'll try to go so close as possible without moving anything. Just wait, Armen, I'm coming to you. This is the problem with the live presentation. Camera crew are not fit.
Yeah, but now we are showing all the
So we're in the lab, I have no problem. They've seen enough of it. I had a guy here who says, I know your lab fully because I see everything. Everybody shows different things. So now we see Armen. What we're trying to do is he has produced a motor which is only the central column rotates inside a Gans, which the outside is like a light bulb. You gotta hold it a little bit till the light bulb comes on. We'll see it in a minute. So yeah, you're going too high for my camera. So this Armen, you got to show it again because we missed the picture. No, show the bottom. You go too high. Go down a bit, please. So you're too high. This is the light bulb. What we're trying to do is the center pin is nano material. Then the plastic is nano coated, and then the CO2 is added in it and it's sealed. Armen has connected to a motor and then put it on the stand. And then now he's filling up the Gans of copper oxide to see the interaction of the copper oxide with everything else inside to see if we can achieve light. These tests we can only do in the evenings because there's too much light in the center. So now you see the full setup. Can you switch the light off and see if you see anything or it's not enough there? No, we don't see any light. Yes, we do. No, we don't. It's the light from the... No, there's a light from the reflection of the computers. No, we don't see any light. So we have to increase the speed to see where we go. Here at the moment we have... It's okay. Armen, you can put the lights on. Thank you. So what you see, we are back on lights, just showing different speeds of flow. There is not enough Gans. You got to go right to where the Gans is. So we are back in light. You see us again. So that's one experiment Armen is doing to create light. There is another experiment which is Marko doing. We are creating a flow between two different strength of copper oxide.
Yeah.
You speak your term. Explain what you're doing there, please. Just wait. Hey, the
There are two circuits.
Just wait, you're not there yet. Your finger is not there yet. Okay, you start explaining this in the circuit.
In this system, there are two circuits. One is inside, one is on the outside. And in this circuit, Gans material is rotating. We have two motors. One is here, and one is here. And in this experiment, I try different Gans material. First with CO2 Gans in both circuits. Then I changed to CO2 with salt water. Then I changed in one circuit CO2 Gans and copper oxide Gans. And now the last experiment is in both circuits with copper oxide Gans. We are trying to get light out of this experiment.
Now we stop with the I lost the view. Use the camera again. No. Nothing noticing. Yep. So
It's a little bit of delay.
huh?
It's a little bit of delay.
Delay, there is no problem. So what you see Marko is showing is another test which is going on. We have another test here which is done by John, is in the same line of work, but this time the same as reverse to the others. The center is static and the flow is outside. Where with Armen's, the center was rotating, the outside was static. So John will explain what he's doing.
So I have inside plastic, transparent plastic, where I put the copper Gans,
Are we live?
and that copper Gans. So that copper Gans inside is in fact sealed with two nano-coated electrodes, copper electrodes on each end. And this is in fact in transparent plastic, and the whole is done with a closed circuit where Gans can flow, and that Gans are started to make CO2 Gans. This piece is only to allow an equilibrium in the pressure, not to have leaks coming out because of the pressure increasing if I have a closed circuit. So this is only what is done for releasing pressure inside and not have leaks in the pump. So this pump is connected to a motor. And well, for the moment, no results yet, but I hope I will see results later.
So now you can see we spend 8-10 hours a day just playing like this. We play big boys games. No Ferraris and no Lamborghinis and no Formula One race cars. So it's the first time we've taken you around the lab live as we work, and in so many ways that's how it should be. I'll explain to you on Thursday how people are abusing this openness of ours. Very interesting. I'll explain to you what is happening in the background of the Keshe Foundation. This is important because what we are showing and what we are doing, even it's now in public knowledge and public information live. They are trying to write patents against it that they block the technology. It's done by our favorite people in Belgium. They are writing patents to block the technology for what is already common. They think people are stupid, they don't know what's going on. So that's why I decided from now on, we go live with everything that everybody can see, and this blocks another move to write patents on what is done is here, and it gets reported back to them. So they are literally writing patent on what we show to block that it's ours, but in a way as is recorded, and we keep a copy of all recorded. And it's the job of people like Vince and Rick to keep an offline backup that this can stop and be part of the public knowledge. What happens is that we show what we are doing, and we make these live presentations very, very, very much part of the structure of the work. As the University Institute website is getting completed by our webmasters.
Maybe
so we're going to go a little bit lower. Yeah. The front needs to go. Let's see. So you see something very correctly here, I think, and that is.
Try to focus this.
I can't see that. You see it? I don't see it. The weight now is about, it's gone down to 1108 again. The system is hanging, it's solid, there's no need for it. You see, we should go up with the weight scale, and they can see the reactors. They can't see the reactors.
They can see something here.
Can they?
Yeah, here is a little bit of the lag.
So we try to adjust. They say never work with the scientists, animals, and children live online, because you don't know what they do next. So you can see the most of the system in the video.
More because here
you see now it flicks between 1108. The system in the background now is pinned by 4 pins, so it's totally, absolutely static. The changes comes through the flow.
we need to go more down, I think. If we want to go more down.
I think we gotta go with the lower legs first. No, the lower legs.
Okay.
The book is still there. The book moved a long time ago. Let it run for a day or two. The book hasn't moved yet, right?
Okay, I think this.
I was afraid that would. It can't happen because now we have live and everything is on, and it's important that all the things we do in the workshop gets transcribed and go into public. This is one of the main jobs you see in the New Zealand people doing it and the others. You have to transcribe all the workshops very fast and put it as a publication. That it literally blows the Belgian organization trying to patent rights against our discoveries into the window because it's already live. And secondly, something a lot of you don't know, we have signed, sealed, and put things in the courts in Belgium with some 800 pages of document registered. So anybody makes any claim, these are done over 7 years ago, it literally annihilates everything else, so it's not valid. But this is a new trick which the Belgian team have come up with, and our security people are monitoring what they are doing. So they've written patent and trying to backdate the patent because they control the patent office in Belgium. But as it's not in the European patent, it's not applicable. It's a fraud. So we know what's happening. Unfortunately, there are a bunch of people who don't understand how the things work, and they think they can go with the Belgian patent and not backdate it because they sit in the patent office themselves. So don't be afraid. Okay, we are at 11:08 kilogram. It's about 8 o'clock our time in Belgium, in Italy. And we start winding up for tonight. If anything interesting, I'm sure we'll see tomorrow morning.
I had the lead
It's good night from us here. We'll see you tomorrow if you go back on live stream. It says, we are not afraid they couldn't patent the universe. According to the World Patent Office, it's a natural phenomenon, nobody can patent it. All the best, see you tomorrow. Let us know if you fly overnight. Ah, the weight is dropping to 1104 from 1106, 1108. Very strange. No, no, this instructor, it was 11 over 8 when we left. Go over there. Okay.
Dad, what
Okay.
happens if you touch?
You don't touch anything because that's what it's supposed to do. It's 11:04.
Then if you touch it, what happens?